Good morning, dear students. How are you today? We begin a new week and we have a lot to do. And I'm presenting you today a new assignment that has to do with identities. This is a lot of fun. It looks at first a little bit challenging, but I assure you that it's a lot of fun. If you have the algebra skills, it's just kind of a puzzle, okay? And let's begin with this one, with the first one, which is says sine of theta equals 4/5, where theta is an angle between 360 and 450, and they're asking us to find the sine of 2 theta. Now, for sure, we could just establish here, find theta, and then how much is 2 theta, and then just apply the sine. For sure, we could do that, but there's other ways to do it that will give us an exact solution, and that's what it says here. Find the exact value of each, right? So to do that, we're going to use the identities, and you may remember I gave you this worksheet. If you don't remember or you don't have it, don't worry, because I'm gonna link it below the video. Okay. Now here you have a lot of formulas. It's actually overwhelming, isn't it? And we have to try to find the one that is giving us the sine of 2 theta. So which one here do you think it has the sine of 2 theta? So what do you think? Mick, can you try to find it? Come on, Mick. I know it's not easy, but I'm pretty sure you can find it. You just look closely. Here. Where, Mick? Here. Sine of 2 theta. You're right. It's here. You have a really good searching skills, Mick. Yes, I do. Good. So now that we find the formula, sine of 2 theta equals 2 times sine of theta cosine of theta. We're going to write it down. So I'm going to write it down. We have the formula says the sine of 2 theta equals 2 sine of theta times cosine of theta. Okay? And the problem says that actually we have to find this, but they're giving us that the sine of theta equals 4/5. That's between 360 and 450. Okay. Okay. Now let's have a look at this. You see here? So we have the value, right? We have that sine of theta, it's 4/5. So we can just substitute this in here. But we're still missing cosine of theta. So we have sine of theta and we're missing cosine of theta, right? There's many ways to do that, but I'll show you. It's maybe the longer way, but it works always, okay? So if we go back to the formula, we're gonna see there is the formula that it relates the sine and the cosine. Sine of sine square plus cosine square of the same angle give us 1. Actually, if you think about it, and I'm gonna show you now the unit circle again, okay? If I show you the unit circle again, okay? And you remember, this is the sine, right? This is the sine of an angle. This would be the sine of 131, right? So this would be one side. This would be another leg of a right triangle, right? Which is the cosine of 131, and this would be 1. So because this is a right triangle and this is the sine square plus cosine square equals 1 square. So what this is trying to tell us, this formula, is this is that if I have a sine square plus a cosine square, it's always going to be 1 as long as it's the same angle. Okay, because this is the Pythagoras theorem for a right angle, right? So that's what it is. So we can use this to find the cosine. As we have the sine, when you always have the sine, you can easily find the cosine. So we have, again, we write this formula down. We have the sine square of an angle plus the cosine square of an angle equals 1, right? How much is the sine? It's 4/5. So we have 4/5 square plus cosine square equals 1. So this is going to be 16/25 plus cosine square equals 1. Now I just move this to the other side. It's like doing minus 16/25 both sides, right? So we have cosine square equals 1 minus 16/25. Now to subtract this, we need the same denominator. So we're gonna do 25/25, correct? And now we got cosine square equals, this is going to be 9, right? 9/25. Now we take the square root. Sorry. What we're doing now is square rooting both sides, okay? So what we're going to have is square root of 9/25, and remember I have to add a plus and a minus, okay? So cosine is going to be, this is going to be 3/5 plus minus, okay? Now, because they say that the angle theta is between, okay, let's look at this, okay? Because this is important. This reflection is important right now. We need to know, actually, it says between 360 and 450. And I would like to show you something. This is a new thing that I have not shown you before. This is about coterminal angles. And I would like to know the angle 360. I mean, let's look like 360. I have to go a full circle to find a 360. Right? And if I keep going, I'm gonna find actually the 450 that we have there. So let me show you. It's between 360 and 450, this angle, right? So now I'm having a 450. So 450 is the same as 90, while 360 is, right? So that means, and 360 is here. So it's really difficult to, okay, now from 360 to 450. So actually this is in the same, in the first quadrant. It's from here to here. So let me show you something that is important. Let's look at how the sine and the cosine behaves when it comes to sines. So cosine of an angle and sine of an angle. Yeah. So let's look at it. Let's go back to the unit circle app, and I want to know when the sign is positive and when it's negative. Remember that we call this will be the first quadrant from here to here. This is what we call the first quadrant. This is what we call the second one. Okay, from 0 to 90, the first one. From 90 to 180, the second one. From 180 to 270, the third one. And from 270 to 360, the fourth one. Okay, we use Roman numbers usually. So again, the first quadrant. So let's look at the first quadrant. If I move this, you can see that the sign is always positive during the first quadrant. Do you see that it's always positive? When I go to the second one, it's still positive. So for the sign, this is positive. The first quadrant is positive, second quadrant is positive. If I keep going and I keep looking at the sign, look at for the third one, the value is negative. For the fourth one, the value is still negative. So that's how the sign behaves. Positive, positive, negative, negative. While the cosine, if we look at the cosine, for the first one is positive. So that's positive. Then for the second quadrant, as you can see, the cosine turns to negative. So that's going to be negative. And then the third one is negative, and the third one is negative, and the fourth one is positive. So negative, positive. Okay, so it's really important to have this in mind to solve these problems. Okay, now because we got actually positive and negative here as a solutions, but it says that theta is between 360 and 450, which is the first quadrant. Can the cosine be negative in the first quadrant? No, it can't. And because it can't, there's only one possible solution. It's the positive one. So we're going to avoid the negative. So cosine of theta is going to be 3/5. Okay? Now that we have the cosine, the value of the cosine, we can finish solving this. The sine was 4/5. The cosine was 3/5. I just multiply, right? That's going to be, remember, when we multiply fractions, the top with the top. Okay, so 2, this is still the top because this is 2/1. So 2 times 4 is 8, times 3 is 24. So this is 24, and then 5 times 5 is 25. So that's the answer, the exact answer for this problem. And if you compare this answer with the answer you have at the bottom of the answer sheet, you're gonna see that it's correct. Now, before I finish the video, I would like to talk about the next problem. You have sine of theta equals square root of 5/3. Now this is in radians. Remember that you can easily convert radians to degrees. Okay, so to exactly find where you're at, so let me do that for you. Okay, so again, for the second one, if you want to find how much this is exactly that, whereas 5 pi, that's the second one, 5 pi/2. Okay, remember that to convert this 5 pi/2 to radians, what we have to do, to degrees, what we have to do is times 180/pi. So the pi's cancel, and you can have degrees. So if you do that with a calculator, right, the pi goes away, so you don't have to worry about the pi, and you have 5 times 180 over 2, which is 450, right? So, and 450, it's coterminal with 90, right? So that goes from 90, and then 3 pi. Let's think about 3 pi. 2 pi is 360, right? And a pi is 180. So that means that if we have 3 pi, that means that we have 2 pi, and then we have the 1 pi more. So we're at 180. So that means that this is actually the second quadrant. So we are in here, the second quadrant, and that's very important again. Okay, and yeah, the last thing I want to talk about is, again, we have to find this tangent of 2 theta. Where is that here on the paper? So here we have tangent of 2 theta. It's 2 tangent of theta and then over 1 minus tangent squared. So we need actually to find tangent of 2 theta, we need tangent. But here we have a sine. And I want to tell you that in this paper, there's one equation missing, which is the definition of tangent. And we're going to write it here. Tangent of theta is actually sine of theta over cosine of theta. Okay? And this, you're going to use this formula, okay, often. Again, here we have sine of theta. Using this one here, we can find cosine of theta the way we did in the previous problem. And then having sine and cosine, you can find tangent using this equation. Once you have tangent, you can actually just compute tangent of 2 theta using this last formula here. So it's like a game of formulas using this one, that one, until you get the right answer. Now, for the this type where you're being asked cosine of theta over 2 or tangent of theta over 2, here you have the formulas for the half angle of formulas. So again, if you're trying to find sine of theta over 2, you will need cosine. Again, if you don't have cosine, you can use any of this one or the Pythagoras one to find the missing one. So it's just the same game over and over. I hope it helps. Be careful when you have negative. That means that actually this is on the third quadrant because it's between pi and 3 pi over 2. So that's 180 to 70. So that's happening on the third quadrant. Okay, so again, after this explanation, you can do all of them. I hope it helps.